Hey, welcome back. Today we are talking about something absolutely essential in machine learning, feature engineering. If you've been working on ML projects, you know it's not just about raw data. To get good results, you need to transform that data into something your model can actually use. Let's break it down. What is feature engineering? Feature engineering is the process of turning raw data into meaningful features that machine learning models can understand. It's like taking unpolished ingredients and turning them into a delicious meal for your model to digest. Without the right features, even the best algorithm won't do much for you. Here's the kicker: the quality of your features is often more important than the complexity of your algorithm. Even a simple model can outperform a complex one if it's fed good features. So, creating solid features is where you should focus. It's more impactful than just fine tuning hyperparameters or trying fancy algorithms. Learned with engineered features. So, what's the difference between learned features and engineered features? Engineered features require you to put in some work using domain knowledge and manual effort to create features that make sense for the model. On the other hand, learned features are automatically extracted during training, especially in deep learning models. But even with powerful techniques like deep learning, feature engineering still matters. You need to pick the right inputs for the model to process. Common feature engineering operations. Let's talk about a few common techniques you'll use in feature engineering. Missing values, a huge one. You can either delete or impute the missing data. Both have pros and cons, so you'll need to decide which one works best. Scaling is key, especially if you've got features with different ranges. Without it, your model might give too much importance to features with higher values. Discretization is when you turn continuous values into discrete ones. This can help in some cases, but it's not always necessary. For categorical features, you'll need to encode them into a numerical format. Methods like one-hot encoding or embedding layers are popular here. And then there's feature crossing, which means combining two or more features to capture relationships that the individual features might miss. If you're working with sequences, think text or time series. You might use positional embeddings to represent the order or position of elements. Data leakage. Now, let's touch on data leakage. This happens when information from your test or validation set leaks into the training process, which gives you unrealistic results. It's sneaky and it can make your model seem better than it really is. Always check for high correlations between features or run ablation studies to test how the model performs when features are removed. Engineering good features. When you're engineering features, think about feature importance. You want to know which features are actually driving performance. Get rid of the ones that aren't helping. Also, make sure your features generalize well. If a feature only works for a small part of the dataset, it might not be helpful when you deploy the model. Always check the distribution and coverage to make sure the feature will hold up in the real world. Key considerations. To wrap things up, here are a few things to keep in mind. Understand your data's journey, how it's generated, collected, and processed. Track data lineage so you can spot any issues early. Feature engineering isn't a one time thing, it's an ongoing process. Finally, it's a mix of creativity, intuition, and domain expertise. Feature engineering isn't easy, but when done right, it can elevate your machine learning game. If you found this helpful, make sure to like and subscribe. And remember, next time you're building a model, focus on those features. They're the foundation of success. Catch you in the next one.